The hardest part of a journey isn't the finish line, it's the first 10 feet. In physics, this is called static friction. It is mathematically harder to move an object that is standing still than it is to keep a moving object in motion. This is why 0 to 1 feels like a war, while 1 to 100 feels like a breeze. You aren't fighting a lack of skill, you are fighting the molecular weld of the status quo. To break it, you don't need a massive push. You need a nucleation point. A tiny, microscopic wind that gives the rest of your life permission to change. Once that wheel moves even a millimeter, the physics change. You move from static friction to kinetic momentum. The weight of the wheel that was holding you back suddenly starts working for you. Stop trying to finish, just try to break the weld. Once you move, the universe does the rest of the math for you. You feel like you're failing because you can't see the steam yet. You've been working, pushing, and heating your project for months, and the surface still looks perfectly still. But here is the math you weren't taught. Success is a phase transition, not a ramp. Think about water. From 1 degree to 99 degrees, it's just hot water. It looks the same, it acts the same, and it has zero power. To an outsider, there is no difference between a pot at 20 degrees and a pot at 99. But at 100 degrees, the entire system reboots. It turns into steam. It gains the power to move a locomotive. Most people quit at 98 degrees because they don't understand the physics of the latent heat. Every degree of effort you've put in is being stored in the molecular lattice of your work. You aren't stuck. You are just at 99. Don't let the silence of the surface fool you. You are 1 degree away from the reboot. In the world of physics, magnetism is the enemy of the flow. If you want a material to have zero resistance, you usually have to keep it far away from magnets. But this week, a team of scientists tried to kill a material called uranium ditelluride with a massive 40 Tesla magnetic field. And then something impossible happened. The material didn't break. It didn't lose its flow. It resurrected. At the exact point where it should have died, it formed a toroidal halo, a donut-shaped shield of energy that allowed it to keep moving with zero resistance. The pressure didn't stop the flow. The pressure became the shield. This isn't just about uranium. It's a blueprint for life. When the pressure of the world hits a critical threshold, don't fight it. Use the math of the torus. Shift your geometry so the very force intended to crush you becomes the field that protects you. Everything we know about memory is about to be rebooted. On March 8, 2026, we officially entered the age of the biological hard drive. Scientists have created a DNA-based storage system that is now completely rewritable. Why does this matter? Because a single gram of DNA can store 215,000 terabytes of data. That's every movie ever made, every book ever written, and every memory you've ever had, all fitting into a volume smaller than a red blood cell. We are moving from the digital age to the eternal age. Your grandchildren won't look at a photo album or a cloud drive. They will read your life from a drop of water. This isn't just tech, it's a shift in our reality. Information isn't a file anymore, it's a biological mass. We are building an archive that can last for centuries without a single server or a single wire. The future isn't in the silicon, it's in the code of life itself. Most people think their brain is a dictatorship. You want to move your hand, so your motor cortex sends a command, and the hand moves. Simple, right? Wrong. A massive neuroscience breakthrough just proved that your brain is actually a democracy, and the Senate is hidden at the base of your skull. It's called the medulla. Before any signal reaches your fingers, it has to pass through this ancient crossroads. This isn't just a wire, it's an edge processor. It filters out the noise of your own heartbeat and your breathing so that your hand remains quiet. You don't actually have a steady hand, you have a steady brainstem. This discovery changes everything we know about human precision, from how a surgeon operates to how an artist draws a single, perfect line. We aren't just drivers of our bodies, we are the observers of a highly tuned biological committee.